what I wanted to do was quickly just do the things that I started talking about last time. I started to talk about analog and digital, but this is not the only thing the syllabus wants you to know. To just know what is a digital signal, what is an analog signal. No. That's not. Although we said analog signal is just a continuous signal, okay? It varies continuously. Just say it's a signal that varies continuously. For digital signal, you say it is a signal that only takes. Here it says only carries. You can also say only takes discrete values. Okay? It only takes discrete values. It only varies between 0 and 1. So if it's a digital signal, it's either a 0 or it will be a 1. You hear me? Hello? Students, this is a digital signal. A digital signal is just one which is going to vary between 0 and 1. Don't forget to say it. It will be either on or off. That's a digital signal. And that is how I move. Now, what we are going to need to do is we are going to need to put some of the things that I need you to know about it, about the two. So let me say comparing. I'll then give you the advantages. Let's do it. Comparing or comparison. Well, let me say analog. I'm going to be moving fast, okay? So I don't want to waste my time on unnecessary things, okay? Or let me just say transmission of sound. I'll put the table at the end. Let me just tell you what happens when sound is being transmitted. Say transmission of sound. When you do transmission of sound, here's what I want you to know, okay? Here's what I want you to know. Is that we said that the human voice is an analog signal. So naturally, before you talk about transmitting any sound, naturally sound is an analog signal. Naturally sound, it is analog. Now, when you want to transmit it, it means you are now talking about communication. It has to be converted to a digital signal. It can only be transmitted digitally. So, listen, in communication, signals are converted. So write that to say naturally, natural sound is an analog signal. Naturally. Okay? But the problem with that analog signal is, number one, it is very difficult to check for errors. Number two, it is affected by what we call noise. Noise, which means sounds we don't want. So we have to convert it to digital during transmission. So say, but communication systems often transmit sound digitally. Okay? Digitally. I just have to quickly, because there's a question, it comes in past papers, so I just have to make sure I don't leave anything. So I want you to say, the signal is converted before transmission, okay? From analog to digital for transmission. Are we together? So write it like this. Here is the process. Here is the process of communication. Everybody should just know this. Here's what happens. First is before transmission. It goes analog to digital. This is before transmission. Then after transmission, are you writing with me? After transmission, it now goes digital back to analog. Are we together? it goes analog to digital. And I want you to then put in brackets to say, this is what you will know as digital sampling. It's just called sampling, but you have to know digital sampling at IGCSE. Have you written? Have you written? So you come here now, since you know it happens before transmission, where an analog, the normal thing, is converted to digital. Then after transmission, we'll convert back. So then you should know, let me say 3 or 4 lines, 2 lines. This thing, this digital sampling, write it to say, this is the conversion of an analog signal into a digital signal. How? How do you convert it? Here is what you do. You take the measurement here, then you take the measurement here, then you take the measurement here, then here, then here, then here. You don't take the whole. You ignore some of these values here. You ignore them. So you start pretending like it was only here, then it jumped to 0, then it jumped to here, then it jumped to 0, then it jumped to here. That's what you will pretend to do. And this one, which was at 1 but in the negative, will be flipped, so it will be back here. So that is what you will pretend. So that is how you will do sampling. So it's converting an analog, which is a continuous signal, into a signal that only takes discrete values, okay, which is a digital signal. How? By taking measurements, at intervals, or you can say at regular intervals. You just take values at intervals. I said you don't take all of them. You take at intervals. Okay? You just record it, but only at intervals. Now, you jump. Now, you jump. Now, you jump. Now, you jump. And you are, if you are taken here, and here, and here, and here, and here, you do it like this. Then you go down. Then you pretend like it was always like this. Then you go up. Then you pretend like it was this. Then you go down. Then you pretend like it was this. Then you go up. Then you pretend like this. Then you go down. This is what will be happening. Okay? Are we together, students? So we pretend like it was always like that. We just smoothen it. It's now smoothening. Okay? You understand what sampling is? That's all you gotta know. We move on. That's all you have to know. Don't worry, don't. Right. Now, let's talk about it. Next thing. I don't want to waste time on, I want to draw diagrams, but I just want to finish this. Put noise. Can somebody write noise here? Write noise. Then I'll just tell you the advantage. Then you'll be done. Noise is right here. This is unwanted interference, which distorts signals. Noise is unwanted interference which distorts signals. Okay? It mixes permanently. It mixes permanently with analog signals and is hard to remove. I'm now just telling you why we hate them. Digital signals have an advantage because digital signals cannot read noise. They cannot. Digital signals only recognize 1 or 0. So the signal can be regenerated cleanly. I want to explain what that means. Yes. Regeneration. Okay, I will do it. We'll do it. Yes, wait 10 minutes, just a few minutes. It will be cleaned. So the signal is cleaned or it is rebuilt. Just write for me this. Yes, we'll do it. We'll do it, LGK, I promise, okay? So, everybody, what I want you to know is that when you have an analog signal, it has, number one, I'm going to give you the list right now, but one big problem that it will have, which you may be asked, and it can be 2 marks, is to explain this regeneration or to tell us why it's necessary. What you should know is that analog signals mix with noise, which is unwanted sounds, and they do it permanently and it's hard to remove. So what happens is we use digital signals because you can regenerate them or clean up. Are we together? Digital signals, they recognize 1 and 0, so you can clean them up. Anything which is not a 1 or a 0, you know it's noise, so you can cut it off. It will only be 1s and 0s and you have your signal. So that's good. So digital signal, regeneration. That means we can clean up the noise. We can rebuild them. Analog signal, the noise is hard to remove. It mixes permanently with the sound. So let's now write advantages. When you write, you'll be asked, what are the advantages? Advantages of digital signals are 1, less noise. Write this. It's boring, but we have to know it. Why? Because signal can be regenerated. Number 2, it has, say this, higher or larger, let me say larger range. Why? Because these are advantages of digital signals, why we convert, why we do sampling. Because signals are repeatedly restored. Then 3 and final, faster, or let me say higher data rate, transmission rate, because digital signals have faster transmission. So, what happens in communication? What happens in communication? An analog signal, before transmission, is converted to digital. Then it is transmitted faster, with less noise, and for a longer or a larger range. Can go further. If you have this analog signal, it will be, you will lose some decibels. Eh? We call it attenuation. You do it when you're in A level. Okay? When you do this chapter called communication. If it's digital signal, you don't have to worry about that. It can have a larger range. Are we together? Are we together? It is a larger range. Good. And less noise. And you can create a clean signal by regeneration. Everybody, are we good on this one? LGK, are we good on this? Okay. Now, last part. Talk about dispersion. And then we can do questions. Can you write with me? Dispersion of light. This is the last part. Come on. Last one. Dispersion of light. Write with me to say dispersion of light. Right. And I'm going to explain, then show you the diagrams. To disperse is like to separate. White light is a combination of all colors. Then black, this means absence of light. When we say combination of all colors, say the 7 primary colors. Okay? Right here to say. Let me write it below to say. White light is a mixture. Okay? That's the word. Mixture of all the colors of visible light. Of all the colors of visible light. White is not one color. That's the biggest mistake that you can make. White is not just a color, like one color. No. White is what you get when you combine all the 7 primary colors. All the 7 colors together, they'll give you white. Okay? Are we together? So, I want you to say all of the colors, or all of the 7 colors of visible light. And you should remember them by writing Roy, then you say G, then you say BIV. These are the different colors that are there for visible light. Visible light is the light we see with our eyes. So if you say Roy G BIV, you're going to get all the 7 colors. This is red. This is orange. Let me try to. Red. Orange. Yellow. You can see the colors on this notepad are kind of following that order. Green. Can you see that? Blue. Okay. Indigo. violet. Can you see? Students? Hello? These are the colors. These are the 7 primary colors. So here is what happens. Why are you telling us about the 7 primary colors, sir? What is important there? How can you do that? What are you trying to? What the key word? Write for me this very important statement. Okay? Remember that when we say the 7 colors of visible light is the only part of the lights. We have those lights, these armivoxy, radio wave, microwave, all those are types of lights, but we can't see them. The only part which we can see is the visible. And that visible has 7 colors. And what I want you to know is that these are the 7 colors of visible light. And what I want you to know is that they have different, because they are lights. They are lights. They are all visible lights, so they all move at the speed of light. If you look at the wave. But what I want you to know is that they all have different wavelength and frequency. So if you were to say wavelength, I don't need you to know the wavelength, okay? But what I would need you to know maybe is to say, let me not make you have a table. I want you to say wavelength. Wavelength, this one has the longest red. Here's the longest wavelength. And this one has the shortest wavelength. Are we together? Then for frequency, this one will obviously, if it has the longest or largest wavelength, that means it obviously has the shortest frequency. They don't appear much because they are far away from each other. Then this one will have the highest frequency. Are we together? This one will have the highest frequency. Are we together, students? Shortest, then highest. Red, in terms of frequency. Red, in terms of frequency, is rubbish. It has short frequency. But in terms of wavelength, it's the guy. So what does that translate to? What does that translate to? What I want you to know, when we say dispersion of light, let me maybe write here to say dispersion of light. Give me one second. Just write to say dispersion is splitting of white light. I'm back. I just needed ablution, sorry. Thank you. What I was saying was, okay, I wanted you to write what dispersion is. To say it's just the splitting of white light. So write, dispersion is the splitting of white light. And everybody in here knows white light is not white. It's just combination of these 7. So when you take these 7, whoop, bring them together, guess what you get? You get white. So dispersion is the splitting of white light into its component colors. What are the colors? Roy G. Beef. Are we together? Right. Now, here is what we are going to do. The secret is going to be this. Can you all, this is the most important thing. Different colors travel, or let me just say refract differently in glass. Okay? They change the speed differently. So different colors refract differently. They refract differently in glass. What do you mean? They bend differently. That is why they are going to split. So it's going to come as white light. It gets to the glass. Then they will bend, but their bending is different. So you will now see red on, and just below it you see the other one, just below it you see the do you get it? Do you get it? Differently in glass. Write this. Violet refracts the most. This is so important. Red refracts the least. So, are you ready to do one? Students, are you ready to do some diagrams so that we test that? Hello? Hello? Let's do it. Let's do it. We're going to take I'm going to show you through questions what they can do to try and trick you. You guys are not going to be tricked. Anyway, this is like a triangle, right? They call it a prism. So it's going to come as white light. Hit here. Hits here. What we know is that it's not going to continue straight. Everybody knows. This is glass, by the way. And it's coming from air. So we know that in air, they are moving at the same speed. So that's fine. So they're together. But when they are entering glass, they slow down differently. So they bend differently. The one who is going to refract the least is red. But it still refracts. It doesn't continue straight. Okay? The straight path was going to be this one. But it's going to bend slightly. So you're going to see red like this. Okay? So you're going to see red like this. It bends like this. Then when it gets here, just like we already know, it bends again. Right? Because, look, let me just tell you something. If you have a triangle, because you guys are so smart, I trust all of you. You guys are my favorite. I trust all of you. If it had come like this, if it comes like this, look at what happens. Let's not think of it as white. Let's just think of any light. First, I want you to know what happens with general light so that you can understand. When general light comes on a rectangle, my students, listen closely. Let's just finish this. Don't run. Don't run. Here is refraction, okay? Dispersion is a type of refraction, bending. So if light has come like this, it doesn't continue like that. It bends like this. Okay? Slightly. It doesn't have to bend too much. Then it goes on like this. When it gets to the end, listen, it is going to bend again and look exactly like it was looking before. That's a rectangle for you. So if you bring it as white, it is going to separate like this. But when it's leaving, if it's a rectangle, it will come as white. Then separate. When it separates, red will refract the least. Okay, this is going to be red. Okay, it will refract, but the least. Then below that, it's going to separate into many colors, right? Red, then orange. We know Roy, G-Biv. So it's red, then orange. So it's going to be orange here, refracts here. Bends a little bit more. Then yellow, it bends a bit more. Then blue. Now, if you go to Roy G. Beeves, green. So the next would be green. You don't have to put all of them, but you guys kind of understand. So I'm not going to put all of them like this. So this is what it is. The green bends more. So it's about bending. Originally, it should have gone like this, but we said they bend. And we said they bend differently, so it will split. Now, what happens is going to get, if it's a rectangle, it gets here. Orange gets here. Okay, orange. Don't let me down here. Yellow gets here. Okay. Green gets here. If it's a rectangle, then it is going to recombine because it will bend again, but now they are bending back up to exactly where they were. So you see them all come into one like this. They will all come into one. Okay? Which is so hard to show, but they will all come back into one. Like, you don't put them as, come on now. Red will bend slightly like this. Then orange will come, bend, okay, and mix up. And yellow will come, bend, mix up. Green will bend more than all of them. And when it bends more, it will mix up. So at the end of the day, you have something white. Have you seen? Are you seeing? Hello? Can you see this? So what we say about a rectangular, we say that there is no permanent spectrum. This is a spectrum, the splitting of light. It's not permanent. So what you should say is colors recombine into white. Okay? When leaving the rectangular glass block, and we say to you, are you speaking madness? We say to you, are you speaking madness? You say, no, it's not madness. Because naturally, I know and we know that refraction goes opposite on a rectangle. We know that naturally. We know that refraction is like this. Naturally, whether it's not white or, before we talk about for white light, okay, it bends. Okay, it was supposed to continue like this. Let's say it was supposed to continue like this, but it will bend. Then when it gets here, it will bend back to where it was supposed to be. Okay, so that's what happens. Okay, it bends. It was supposed to continue slanted like this, but it's going to bend. But don't worry, when it gets to the other end, it will bend back into the path it was supposed to be. So it will bend back and be exactly where it was supposed to be. So it will be facing exactly what it was supposed to be. Right? That's refraction in a prism. That's how it happens. When it's a glass prism, here's the nice thing. Because the sides are not parallel, look, they are not going to recombine. It's going to bend, but instead of bending back up, it will bend down again. So for refraction, it's like this. It will bend, get here, then bend down again. Then orange, it bends, it gets here, it bends down again. Here it bends, it gets here, it bends down again. Here it bends, it gets here, it bends down again. Here it bends, it gets down, it bends again. Are you seeing? Guys? Yes. This is dispersion when you have something like this. What about if you spin it upside down? Then you have, okay, I'll do it as a question. I'll look for the question, then I'll show you when it's upside down. No, it doesn't. Yes, it's permanent. It doesn't recombine. So you say the spectrum is permanent. Okay? So you have a visible dispersion. Why? Because it's permanent. They don't recombine. For your rectangular prism, it splits inside the glass, but by the time it comes out, it's back to itself. So, yeah. Okay? Are we together? Okay. Anyone with a question? Now, there is one last thing I want you to know before I talk about the others. But the upside down triangle just spins it the other way. When you talk about monochromatic light, it is just light of one color. So it will be just one color, whether it's orange or what, it will be one color only on those colors that we talked about. So because it will need to have one frequency. And the things that can emit such type of light are called lasers. Are we together? So just write it maybe to say monochromatic. Mono means one. So monochromatic light is light of a single frequency. Of a single frequency. In brackets say, or single color. Is light of a single frequency or single color. Okay? Lasers. Do they do monochromatic? Yes. Lasers emit one color only. We know that if there were different colors, they would move differently in different mediums, okay, when they get into glass and whatever. But for monochromatic, it should be the same. So monochromatic, one color only, okay. Lasers emit one color only, therefore one frequency. So if they ask you why are lasers monochromatic, this is why. Are we together? White bulbs are not monochromatic. They do not emit one color only. Are we together? Do you hear me? Yes. It's all right. Can I ask you a question? Which color refracts the most? Which color? Students, which color bends the most? Violet, thank you. Which color has the largest wavelength? Red. We know that red, when it comes to frequency, it's nothing. But when it comes to wavelength, it's everything. And it refracts the least. Okay, thank you. That is important. Well, I don't know. I'll need to look for questions, which we'll do tomorrow. We'll find time. Okay, I'll let you out early. Now because we're done. Lahakwa, show me the question. Oh, you sent me a message. Let me see. Sorry. Oh, you sent me a picture? Okay. Oh, it reduces to 6/13. Good job. Oh, that's good. Let me see. Let me go back to let me go back to the question. That's good. Let me go back to the question right now and see what happened there. $30. Thank you, Simon. I know why. We are picking packets without replacing. So, if this, okay, it's the same thing, but I'll explain it tomorrow. Basically, what I was shown by him is, if we are picking two packets, okay, we are choosing two packets at random. This never said that we are looking and replacing. It never said that. It said we are picking. So if we are picking or choosing them, that means we are selecting, we are taking them out. So the first time we have 13 packets and we are going to choose the first one, its probability is 4/13. The second time we are picking, we will be left with 12. So this should be 12 because we have already chosen one. So it's this, and now we are choosing the second time, so it'll be 12. If that is like that, then whatever, it's reduced, it became 36 over something, which reduced to 1/6 at the, I don't, which one is the, but it makes sense. Why I know it makes sense is we are selecting packets. We are not just checking colors or spinning a dice and whatever. We are actually picking things here. So the total should go down. I'll check with the marking key to make it to confirm, but this sounds more realistic, okay? But I'll explain it again in terms of the totals for those who, so that you just watch out for that one, the totals, because it can cost us, eh? It can cost us. Otherwise, everything was correct, but this total had costed us almost. But the methods are still the same. Nothing changes. Okay, I'll do it and explain it in our questions. Let's do it as a group. Let's agree. What time do you want to meet me tomorrow? Tell me. Students, my students, what time do you want to meet me tomorrow? During the day. What time? Oh, some are saying after lunch, some are saying before lunch. So let's do the polls. Do you want to meet me before lunch? Do you want to meet me like what time? Everybody? Okay, before lunch, some are not available. After lunch, is there anyone who's going out after lunch? Like after lunch, that's when you're going out. Is there anyone who's like that? Is there anyone? Nobody. So after lunch, let's meet. Oh, Matilda, you said you're going out, Matilda? Okay, good. Antonisha, are you going out after lunch? After lunch. Okay, good. So try not to go out unless it's absolutely, absolutely necessary. So weddings, we love them, but not now, guys. Unless it's you have to really go. So we'll meet tomorrow after lunch, my time. So I'm going to put the link early so that you can see it, and then we'll meet after lunch. After lunch, it could be 1 or 2, whatever. But yes, after lunch tomorrow. Cheers, everybody. We'll do questions on dispersion, and we'll see how the exams actually ask us, but we are not afraid of them at all. I'll just try to do all the chapter 3 together and see if there's anything to fix. And then we can now go to chapter 6, then we'll do chapter 5, 4, and we'll brush up 1 and 2 closer to exams. Don't sleep, guys. Hey, exams. When I say exams, I start to feel the pressure because you're only left with like 5 months and some days, or just 5 months. So yeah, we have to be very perfect right now. Goodbye. I'll gather the questions I want to do for several subjects tomorrow. Now that I'm almost done with the big topics, it makes it much easier. Like for chem, I'm going to, if people are good at organic chem, the rest I'll make you so good, so easy. Because the other topics, I know exactly what they ask, and they are so easy, so I don't want anyone to fear them, okay? Like if it's chemical energetics, I was explaining it to another student yesterday, exactly the bond energies, that's what they'll ask you. So I'll show you what they'll ask. Then for chemical reactions, chapter 6, I'll explain. For acids and bases, I'll explain what they ask. It's easy. So make sure tomorrow we meet after lunch and we push. Goodbye.